The next polynomial story problem that we're going to look at is something we call projectile motion. And the idea behind projectile motion is that we're going to have some object flying into the air and then come back down to the ground. And we want to have some way of measuring this. So this could be a ball being thrown, it could be a rocket going up and down, it could be a cannon firing cannonballs. Whatever it is, we've got something flying through the air and gravity is going to pull it back down. And so the particular case that we want to look at now is a model rocket. Let's shrink this so we have plenty of room to look at. So a model rocket is fired straight up into the air. The height s of the rocket in feet as a function of time in seconds can be modeled by the function s of t equals minus 16t squared plus 160t. So notice that we're really nice and we give you the function, but then we're going to ask two questions about it. The first is, when will the height of the rocket be? 384 feet from the ground. And so we're given the height, and we're being asked for the time. Remember, time is an input and height is an output. So we're going to replace the s of t with 384 and set that equal to minus 16t squared plus 160t. Now to make our lives a little bit easier, I'm going to add 16t squared and 160t to both sides so that we get the function 16t squared minus 160t plus 384 equals 0. And the reason I did this was so that I could have a positive t squared. Now we're going to look for greatest common factor, and it should be straightforward to see that a 4 goes into everything. So if we factor out a 4, there's 4t squared minus 40t plus 96 equals 0. Well, we can go a little bit farther than this. We can pull out another 4, leaving us 16, which leaves t squared minus 10t plus 24 equals 0. And we don't worry about the 16 because we can divide 16 into both sides, making this go to a 1 and the 0 staying as a 0. So now we just need a factor, t squared minus 10t plus 24 equals 0. So that's t minus 4, t minus 6 equals 0, which means 4 seconds and 6 seconds after launch will be at 384 feet. Meaning that it's gone up, and when it comes back down, it takes 4 seconds to get up and 6 seconds to get back down. So one more second gets to the top and then comes back down. The next question is, when will the rocket strike the ground? It may seem like we're missing information, but remember we're launched from the ground. That means our ground is at 0. So when we rewrite our function, we're going to replace s of t with the 0. We're going to set this equal to minus 16t squared plus 160t, which means we can factor out a minus 16. There's a t squared minus 10t. Now we can factor out a t as well. So we have minus 16t and t minus 10 equals 0. We are not worried about the minus 16 because it's a number. So we get t equals 0 or t equals 10. So it's at the ground at 0 seconds, which we knew. 10 seconds later, it's hit the ground. So the answer is it'll strike the ground at 10 seconds. This was at 4 or at 6 seconds. And so we've successfully answered the question.